So how do you generate a QR code in a Spring Boot app? You'll find out in this video, in which we'll generate QR codes to identify tickets to events. This is part 9 and the penultimate part of the Event Ticket Platform build series. In the next and final part in this series, we'll implement the logic to scan these QR codes and validate our tickets. All of the resources, including the Spring Boot backend source code and the React frontend source code, can be downloaded for free from the Devtiro Discord server. I'll put a link in the description below so you too can join the community. Okay, with that all covered, let's get started. In this module, we're going to add the new users and roles that we'll need for our event ticket platform. The module is structured like this. We'll first configure the attendee user and role. We'll configure the organizer role, remembering that we already have the organizer user. We'll configure the staff user and role. And now for the learning objectives. So by the end of this module, you'll be able to add the organizer role, attendee user and role to Keycloak, and add the staff user and role to Keycloak. So with this covered, let's get started. In this lesson, we're going to add the attendee user and the attendee role to Keycloak. So here we are on localhost 1990. So this is the Keycloak admin login. So I'm going to log in with the admin username and the admin password. Okay, so we are logged in here. The first thing we'll need to do is to make sure that we're on the correct realm. So if we go to manage realms here, we can see we have several realms. We want to make sure that we have the event ticket platform realm active at the moment as our current realm. With that done, let's now go over to our users. So we already have the organizer user that we've been using so far. So we're going to add a new user now. And the username for this one is going to be attendee. And the email address, we'll go with whatever your email address is. And then we'll go with attendee at, and I'll just use Devtiro for mine. Okay, so that's our attendee username. We have a email address there. We'll go with the first name of attendee and the last name of user. And then we're going to create this user. We'll go over to credentials. We'll set a password. And as we are in a dev environment and we just want to be able to log in with a attendee user, we're going to specify the password as password. Obviously don't do this in production. And we're also going to disable temporary to make sure that we don't have to reset the password when we log in as this user. So we now have an attendee user that we can log in with the username attendee and the password of password. The next thing that we'll want to do is to assign a role to this user. And this is how we're going to tell an attendee user from an organizer user from a staff user. So to achieve this, let's open up the menu on the left and we'll go to our realm roles. And we're going to create a role. Now the role name that we're going to go with here is going to be role underscore attendee. And we'll create this, we'll save this. And with this created, we can now go over to our user, the attendee user, go to role mapping, going to assign a role, we'll filter by realm roles, and we're going to assign the role of attendee to this user. So we now have an attendee user with the role of attendee. Now while we're here, let's assign the role organizer to our organizer user. So we'll go back over to the menu on the left, go to realm roles, we're going to create a role, role underscore organizer. Save this, then we'll open this up on the left. We're going to go to users, go to organizer, role mapping, assign role, filter by realm roles, and we're going to assign role organizer to our organizer user. And we can now use this information in both our front end and our back end in order to determine what type of user we are working with. In summary, we added the attendee user to Keycloak, we added the role attendee role to Keycloak, and we added the role organizer role to Keycloak. In this lesson, we're going to add the staff user and the staff role to Keycloak. So here we are back in Keycloak and we are already logged in. We're on the users page. We can access this page from the side menu here. So let's add the staff user. Add user. The username for this one is going to be staff. The email is going to be the same format that we've been using so far. There we go. We can use this flag in order to use our email address, but then differentiate it. So for the first name, we're going to go with staff. And for the last name, we're going to go with user. And we're going to create this new user, go to credentials, set password. We'll go with the very simple and very unsecure string of password, setting temporary to be off. And this is only really appropriate in our local development environment and of course not production. So we have a user, a staff user that we can log in with the username of staff and the password of password now. So let's now deal with the staff role. So let's go to the realm roles here. We'll create a role and we'll call this one role underscore staff. and then we'll click on save. And now if we go over to our users here, look for our staff user, role mapping, assign a role, filter by realm roles, we can assign the role of staff to our staff user. With that, we now have 3 different users. We have an organizer user, we have a attendee user, and we have a staff user, and they each have assigned their own appropriate role. So in summary, we added the staff user to Keycloak, and we added the role staff role to Keycloak. So let's recall what we've achieved in the new users and roles module. In attendee user, we added the attendee user to Keycloak, and we added the role attendee role to Keycloak, and we added the role organizer role to Keycloak. In staff user, we added the staff user to Keycloak, and added the role staff role to Keycloak. In this module, we'll implement the purchase ticket functionality, which also includes generating a QR code. Again, to avoid any confusion, we will not be integrating with a third-party payment provider. We will instead be mocking out the particular payment logic in order to avoid all of the challenges that comes along with processing real payment data. So the module is structured as follows. We'll first design the QR code generation functionality. We'll then implement the QR code generation in the service layer. We'll then implement the ticket purchase in the service layer. We'll then implement the purchase ticket endpoint before testing this new endpoint in the user interface. So now for the learning objectives. So by the end of this module, you'll be able to design the service layer functionality to generate a QR code. Implement the service layer functionality to generate a QR code. Implement the service layer functionality to purchase a ticket. Implement the purchase ticket endpoint, and test the purchase ticket endpoint by using the user interface. So with this covered, let's get started. In this lesson, we'll design our QR code generation functionality. So we're back in our IDE. Let's head over to the entity that represents the QR code. So in domain, entities, and we want QR code here. Here we go. So there's a few things that we'll want to update on this QR code entity now that we know more about our system, having started to build it out. The first thing that I'm going to do is remove the generated value from the ID on QR code. And the reason I've done this is that we want to manually generate the UUID that the QR code uses as the ID before we save it. And the reason we'll want to do that is because we want to bake it into the QR code itself. So when the QR code is scanned, we can use that ID to look up the QR code in the database. Now, the second thing that I'm going to do here is for the value instance variable here, I'm going to specify a column definition of text. And the reason I'm doing this is we're going to store the QR code image in the database. Now, this doesn't scale very well. However, for an initial solution, it's appropriate, I'd say. It would allow us to get moving, get this functionality built with minimal additional infrastructure. The move to specify text rather than the default varchar means that this particular field will expand to fit whatever the size of the contents, which in our case is going to be a base64 encoded QR code image. But just calling it out again, this only goes so far, and we are going to be storing quite a bit more data in the database by base64 encoding and saving images. So bear that in mind if you're looking to scale out a solution like this. So now I'm going to start the application. And the reason I'm doing this is I want to see whether or not changing the column definition to be text will automatically update the type in the database. Because we're using auto DDL, but sometimes you just need to double check. So the application started up. I'm now going to load up AdMiner. So here's AdMiner running on localhost 8888. This is running in our Docker Compose environment. So I'm going to specify PostgreSQL. The username is Postgres. Password is changeMeInProd ! Login. We'll go to our Postgres database, which is the one that we're using. And I'm going to click on QR codes here. So the value is now text. Great. So that means that when we store a base64 encoded image in there, it won't be limited by the default varying character 255 type. So with that done, let's head back to our IDE. Here we are. We can actually stop this running now. We don't need that running. Okay. So if we take a look in our repositories, we're going to want to save and recall QR codes from the database. So let's take this moment to create a repository for our QR code repository, which is going to be an interface. Let's just fix that typo. Okay. And this is going to extend JPA repository, where the type is going to be our QR code and UUID is going to be our ID type. So we now have this QR code repository that we can use. Let's not forget the repository annotation on the top. So let's now, inside of the services here, define a QR code service interface. So we'll say QR code service interface, and this is going to be where we declare the function to generate our QR code. I think this will simply return our QR code entity, and we'll call this generate QR code, and it will take the ticket entity as a argument like so, because we'll need to save the QR code against the ticket. There we go. Now, I think we should handle the case where the QR code generation fails for whatever reason. In order to do that, I'm going to create a custom exception, which is just going to follow the same pattern that we've been doing so far. So I'm going to copy one that we've got. Rather than event not found exception, I'm going to call this one QR code generation exception. And then over in our error controller, or our global exception handler, should I say, we're going to handle it. And again, exactly the same way we've been doing so far, QR code generation exception. And we'll say handle QR code generation exception, making sure that's the type that we pass in. We'll specify the type in our error message. And we're going to return an error, which is unable to generate QR code, and not a bad request, but an internal server error. So this will give the user interface enough information that something's gone wrong, but if we've been unable to generate a QR code, that's definitely a problem within our application rather than something the user has done. So we'll go with a HTTP 500. A few things that we've done in here. We've updated our QR code entity. We've created a QR code repository. We've defined a service with the generate QR code method, and we've created a custom exception to handle the case where we are unable to generate a QR code. So now that we have all of this in play, we can now move on to implementing the generate QR code functionality. In summary, we've updated types in the QR code entity, added the QR code generation exception, and we added the QR code service, we added the QR code repository. In this lesson, we'll implement our QR code generation functionality. So we're back in our IDE. So let's go over to our services here. We'll go to import, and we're going to create a new Java class, calling this one QR code service import, and this will be a Java class. And we'll implement QR code service. And if we hover over here, we implement our methods, generate QR code, and we now have a method stub that we can use. So before we do that, let's add the service annotation, required as constructor. And now we can start to think about how to implement this particular functionality. Now there's already a well-established library for this, and that's crossing. At least I believe it's called crossing. So if we go to pom.xml here, we'll scroll down to just before our test dependencies, and we're going to include these two dependencies here. We're going to need both core and the Java Standard Edition dependencies. I'm going to include those and make sure that we refresh our Maven changes. Very good. So this will allow us to generate our QR code. Now, in order to make good use of this library, I think we should create a bean for it. So up in config here, I'm going to create a new Java class, and I'm going to call this one QR code config. And we're going to put the @configuration annotation on the top here, because we're going to declare a bean inside of this particular config file. So public QR code writer, which you can see comes to us from that library. And we'll call this one QR code writer. And then we're going to return a new QR code writer. And this will now allow us to inject this wherever we do need it. So back in our QR code service import, let's just make a bit more room. I'm going to declare a private final QR code writer, which we'll call QR code writer. And we're also going to need the QR code repository as well, which we'll call QR code repository. So let's get to implementing this. The first thing I'm going to do is generate a UUID. So UUID, random UUID, and I'm going to assign this to a variable called unique ID. And this is going to be the unique ID that we bake into our QR code and then use it to look up the QR code in the database. So it's also going to be the QR code's ID. And this is exactly why we removed the auto generation of the IDs for QR code, because we're going to do it manually. So next we're going to want to generate our QR code. So I'm going to declare a method call, generate QR code image, and we'll say we'll pass in the unique ID here, and we're going to want to assign this to a string called QR code image. So this is going to be base64 encoded. And it's red because this method currently doesn't exist. So we're going to create it like so. And we can now focus on taking a UUID and then returning a base64 encoded QR code image inside of this private method. So the first thing that we're going to want to do is generate something called a bit matrix. So we'll do QR code writer dot encode, and we're going to pass in our unique ID dot toString because we're going to bake in the string representation of our UUID. Next, we're going to specify the barcode format. So we can generate more than just QR codes with this library, but we want a QR code. So barcode format dot, and we want QR code. And now we want to specify the height and the width. So I'm going to create a couple of private static finals up here, and we'll make these just ints, and we'll say QR height, and let's do something like 300 pixels. And then we'll copy that and we'll say QR code width is also going to be 300. We could pass this in as configuration. However, for the moment, we'll just hard code these as statics. So we'll go, what did it ask for next? The width. So we'll go QR code width and then QR code height. And then we should be able to assign this to a variable, which we're going to be calling bit matrix. We are getting a red underline, and that's because it throws an exception. So we'll add that exception to the method signature, and we'll handle that in a moment. So we now have a bit matrix, but what can we do with a bit matrix? Well, we can turn it into a buffered image, and then that will allow us to turn it into a base64 encoded string. So we'll call the matrix to image writer, which has some static methods on there. One is to buffered image. So if we pass in our bit matrix, we now have a buffered image that we can use, just a Java buffered image, which is great because then we can, if we scroll down here, we'll create a byte array output stream like so. We'll say byte array output stream equals a new byte array output stream. And we're putting this inside of the try here because then it will close the byte array output stream when we're done. So let's say image IO, and we're going to write the buffered image, which we should probably rename to be something like QR code image, perhaps, to make it obvious what it is. So we're going to write the QR code image. We're going to write it as the format of PNG, and then we'll pass in our byte array output stream like so. We're getting some red underlined, and that's because we have some unhandled exceptions. So let's add that to the method signature as well. There we go. That's a bit better. So we've written the buffered image to the byte array output stream. So let's get the bytes for this particular byte array output stream. So we're going to say BAOS dot to byte array. We'll assign that to a variable, which we'll call our image bytes. And now we can return using the base64 from Java util get encoder dot encode to string the image bytes like so. And with that, we've been able to generate a QR code image and convert it into a base64 encoded string. However, we do have these exceptions that we do need to handle. So if we scroll up to the top here, we're going to wrap the content of the generate QR code method in a try, like so. And then we'll say catch any exception. We could be a bit more specific. In fact, let's be a bit more specific. So we'll say writer exception or IO exception. Either can be called EX. Oh, copy and paste error. Let's try again. I think I may have copied the wrong one there. Let's try that again. So let's add that to the method signature, IO exception. So now we should be able to specify like so. Very good. So what we'll do in this case then is we'll throw a new QR code generation exception, and we'll say failed to generate QR code. And then we'll pass in the exception that was thrown. And now we can focus on what we're going to do with our base64 QR code image now. Well, we want to save it in the database. So let's create a new QR code. QR code equals new QR code. We decided not to use those builders, remember? And we'll say QR code dot set ID is going to be the unique ID that we generated here. We'll say QR code dot set status. And this is going to be the QR code status of active. QR code set value is going to be our base64 encoded QR code image string. And then we're going to set the ticket, and that's going to be the ticket argument that's been passed in to the method up here. And now we can use our QR code repository dot, and we're going to call save and flush on the basis that we're going to be calling this from a method that's also doing some transactional stuff. So let's just flush straight away. And we're going to pass in the QR code like so. And if we return this, we complete the initial implementation of our method. So we generate a random UUID. We generate our QR code image by going bit matrix to byte array to base64 encoded string. We then create our QR code entity, populate it with the information that we have, including our base64 encoded string. We save it to the database and we return the QR code entity. And with that, we have the initial implementation of the generate QR code method. In summary, we added the crossing dependency and implemented QR code generation. In this lesson, we're going to take the generated QR code logic and use it to implement the ticket purchase logic. So we're back in our IDE here. So let's start by going over to our services, and we're going to create a new Java class inside of here. And we're going to call this one ticket type service. And this is going to be an interface. So I'm doing this on the ticket type service because we're kind of creating a ticket from a ticket type. So it feels like this logic belongs to the ticket type. So inside of this particular interface, I'm going to specify a method that returns a ticket, and we'll call this one purchase ticket. And then it's going to take a UUID, which is going to be the user's ID, the user who's purchasing the ticket of that particular ticket type. And we'll also need the UUID, which represents the ticket type. And that will allow us to generate a ticket from that particular ticket type. Now, before we go ahead and implement this, I think we're going to have a couple of error cases that we'll need to handle. The first one is if we attempt to look up a QR code and can't find it. And the second one is if we try and purchase a ticket and there's no available tickets and the tickets are sold out, then we need to handle that error case too. So over in our exceptions here, I'm going to copy just the generic custom exceptions that we've been using. And the first one that I'm going to create is QR code not found exception. And the second one that I'm going to create is going to be called tickets sold out exception, like so. And then before we implement our functionality, let's just make sure we're handling these exceptions in our global exception handler. So we'll copy this. And first we'll handle the QR code not found exception. So handle QR code not found exception. And we'll set the error message to be QR code not found. And we'll make this an internal server error, I think. That still makes sense because if we can't find the QR code, then something may well have gone wrong. So the next one that we're going to handle is going to be the tickets sold out exception. And we'll update the method to handle this one. And we're going to reply with the error message of tickets sold. We'll say tickets are sold out for this ticket type. And we're going to return the HTTP of bad request, I think. So a HTTP 400. So if the tickets were sold out when the user was trying to purchase it, technically not the user's fault, but it's an error on the client side, I would say. So we're going to go with a HTTP 400. So with that done, we're now able to use these exceptions in the implementation of our functionality. So let's create a new class inside of the services impl, and we'll call this one ticket type service impl, implementing the ticket type service that we've just declared, and we'll hover over the red squiggle and implement those methods. Okay, so before we go any further, I'm going to add @transactional to the top of this annotation because we're going to be dealing with the QR code entities and the ticket type entities and probably ticket entities. So multiple database calls, let's make this transactional so it's atomic. I'm also going to add the service annotation to the top here. And we're going to need a few dependencies. So we'll first need to get hold of the user from the user repository. So we'll say user repository. And to inject that, we're going to need the required arguments constructor. Let's just make a bit more room. So we need to look up the user who's purchasing the ticket. And we decided that any user type can purchase a ticket. We're also going to need a way of retrieving ticket types from the database and also tickets. So I don't believe we yet have a repository for those. So let's create one. So ticket repository is going to be our first one. Extends, we'll go with JPA repository. This one deals with the ticket entity and it's a UUID type, which we'll import like so. And we'll put the repository annotation on top. And I'm simply going to copy this and create a ticket type repository, changing the type to be ticket type rather than ticket. There we go. And then back over in our ticket type service impl, we're going to inject the ticket type repository like so. And then we'll inject the ticket repository also. And then of course, we'll need a way of generating QR codes. So we're going to inject the QR code service, which we'll call QR code service. Okay. So now that we have all of these dependencies, let's go about implementing the logic. So the first thing that we'll do is look up the user repository, find by ID, passing in the user ID, and we'll say or else throw, because this will return an optional. And we're going to throw the new user not found exception, and we'll do a string.format in here, and we'll say user with ID, and then we'll say the ID was not found. And then we can pass in the user ID there, like so. And we'll assign this to a variable, which we'll call user. So we've looked up the user in the database, or we've thrown a user not found exception. Let's now do the same thing with the ticket type. So we'll say ticket type repository dot find by ID, passing in the ticket type ID, or else throw. And I believe, do we have a ticket type not found exception? Yes, we do. Wonderful. So we'll throw one of those. New ticket type not found exception. And we'll copy this string.format. And we'll say ticket type with ID not found, making sure we specify the ticket type ID as the argument there. And then we'll assign this to a variable, which we're going to be calling ticket type. So we now have the user and the ticket type specified by these IDs. Now the next thing that we're going to do is we're going to check that there are tickets available. So we're going to say ticket repository, and we'll want to count up all of the tickets of a certain type. So over in ticket repository, let's add a new method in here. It's going to return an int, and we'll call this one count by ticket type ID. And if we specify a UUID here of ticket type ID like so, then Spring Data JPA is going to work out the query for this particular function. And now we can use it over here by calling count by ticket type ID, passing in ticket type dot get ID, or we could simply use the ticket type ID up here if we wanted to. And we'll call this one purchased tickets. Fix that typo. Purchased tickets of that particular ticket type. Now we're going to want to get the total available tickets. Now, yes, we are using @transactional here. So if an exception is thrown, then everything, all the logic in here is going to be rolled back in the database. However, we are going to have a concurrency challenge if, for example, we get the ticket type repository, we get back the number of available tickets, let's say 100, and let's say two users at near enough the same time get the count, and let's say there's 99 available. If they then both try and purchase a ticket, if we're not accounting for it, it could lead to some inconsistent states in the database. So it's a bit abstract, but in order to account for this, over in the ticket type repository here, which we'll go to like so, we're currently using find by ID, but I think we should create a pessimistic lock. So the way that I'm going to do that is by specifying the function find by ID, but with a lock. So we'll say optional of ticket type. So near enough the same return type as find by ID. We're going to call this one find by ID with lock. And we're going to specify the UUID of ID. However, I think we should probably be a bit explicit with this one. So we're going to say param of ID. And then we can specify that particular variable inside of a query annotation. So before we do that though, let's not forget the lock annotation. And we're going to specify lock mode of pessimistic right. And the reason we need to do this is the default for most databases is going to be, we try and find it. Here we are, read, so optimistic, which allows for this case to take place. So let's just complete this, making sure that we're explicit so everything works. Query, select ticket type from ticket type TT, where ticket type.id equals ID, which is the ID param here. So this will do a find by ID, and we've made sure of it by specifying the query up here with a pessimistic right. So now if we go back, rather than call find by ID on the ticket type repository, find by ID with lock. And what that will mean is if two users get to this point in the code, one will have to wait here while the other one gets the lock and continues on. So let's continue implementing this, and then we'll circle back to this just to make sure we understand it. So purchase tickets, we know how many of those we have. We're now going to go ticket type dot get total available, assigning that to total available. And then we'll say if tickets purchased, or purchase tickets we call it, isn't it? Purchase tickets plus 1 is greater than tickets available, which is total available. Then we're going to throw a new tickets sold out exception. Otherwise, we'll continue, which we'll say to do. So with this logic in mind, then we're basically saying how many purchase tickets are there of this particular ticket type? How many are available? If I purchase one more, will it exceed total available? If it will, throw this ticket sold out exception. If not, continue on to this to-do that we have. So with this implemented, hopefully this lock makes a bit more sense. At transactional will roll back, but it won't necessarily handle this concurrency, which will only really come about when two users try and do this at near enough the same time. So two users come along, one grabs the lock, goes ahead and does his calculation, either continues on or ticket sold out exception, releases the lock, and the second user comes along, and then this calculation, in theory, should always then be correct. So with that done, let's continue on to this to-do. So let's create a ticket. So we'll say ticket, and we'll call this one ticket, equals new ticket, and we're going to set the status to begin with, and that's going to be purchased. And then we're going to set the ticket type, so ticket.set ticket type to be the ticket type object up here, putting that link in place. We're then going to say ticket.set purchaser to the user that we looked up at the top of the method here. And now we'll need to save our ticket. So ticket repository.save ticket, and we'll call this one saved ticket, because we'll need a saved ticket in order to generate a QR code. So QR code service dot generate QR code, passing in our saved ticket. And that should set the link between QR code and ticket. And I'm pretty sure we'll need to do one more save. Maybe we can optimize on this, but let's say repository.save the saved ticket to make sure that link is definitely saved. And then we'll return this. There we go. So I think there is probably some room for optimization in here, but at a high level, we're looking up the user and the ticket type. We're then putting a lock in place so that this ticket sold out functionality is only ever dealt with by one user at any given time. So we work out if there are tickets available to purchase for a particular ticket type. If there's not, we throw a ticket sold out exception. If there are, we create a new ticket entity. We then generate a QR code, setting up the link between ticket and QR code. We then go ahead and save the ticket, returning it from this method. So with that, I believe we have the initial implementation of our purchase ticket functionality. In summary, we implemented the initial purchase ticket functionality. In this lesson, we'll implement the ticket purchase endpoint. So back in our IDE, let's go ahead and create a controller here, and we'll call this one ticket type controller to be consistent with this idea that we're generating a ticket from a ticket type. So this is going to be a REST controller. Let's make a bit more room. So a REST controller, we'll put the required arguments constructor on there because we'll need some dependencies, and we'll specify a request mapping now, where the path of this is going to be /API v1 events, and then we're going to specify the event ID, and then ticket-types, because ticket types are only associated with an event. Now let's specify a private final ticket type service, because we'll need to use this to purchase a ticket. And that endpoint is going to be a post mapping, where the path of this is going to be /. We need the ticket type ID, And let's just say tickets after that, because we're purchasing a ticket, we're generating a ticket from a ticket type. So that should do it. So if we now say public, returning a response entity of void. And we're doing this because we're technically not taking any payment. No information is really passing to and from the server other than the user information, which is the JWT in the header, and the URL information, including the event ID and the ticket type ID. If you're implementing integration with a third-party payment system, this implementation would likely be a bit different, depending on which third-party integration you'd be going with. But for our purposes, response entity void should work. And we'll say purchase ticket. We'll need the JWT, so we'll say authentication principal, passing in the JWT, which we'll say is JWT. And then we'll say path variable, and we'll get hold of the UUID of the ticket type ID, because even though technically ticket types are associated with an event, so we specify the event in the URL here, we're not going to be needing it for this particular functionality. So now that we have the JWT and the ticket type ID, we can call ticket type service dot purchase ticket, and then we'll need to get the JWT from the user. So we're already doing that over on the published event controller here. No, because that one's public. It would have been on the event controller. Here we are. So what might be worth doing is if we create a new package, we'll call this one util, and in here we're going to create a new Java class called JWT utilities or util. Public final class, this is going to be a utility class. So we'll also specify the default constructor as private, like so. And then over in the event controller, so we could use the refactor tools, but I'm simply just going to cut this, go over to the JWT util, paste this in, and make it a public static method, which we can then use over in the event controller by importing it, like so. But then we can also use it over in the ticket type controller by also importing it over here too. So if we pass in the JWT, we now have the UUID representing the user, and now we'll pass in the ticket type ID, and that will purchase a ticket, remembering that purchase ticket, although it does return a ticket entity, we're not going to be returning that to the user, we're just going to be returning void. The user interface isn't going to be displaying the ticket information at this time. So let's return a new response entity, HTTP status of, we'll go with no content because there's technically no content on here. There we go. And with that, we have the initial implementation of our purchase ticket endpoint. In summary, we implemented the purchase ticket endpoint. In this lesson, we'll test our purchase ticket functionality by using the user interface. So back in our IDE, let's go ahead and open up the Maven panel here. We're going to go clean and we're going to go compile. Okay, build success. Let's start our backend application. Okay, very good. So that's the application started up. Let's head over to our browser. Okay, so we are on the attendee landing page. So let's select test event 3. And for this one, we're going to go with the standard entry, I think. Let's just open up the inspect and networks panel here. So let's click on purchase ticket. So we're being asked to log in. So I'm going to log in with the attendee user that we created a moment ago. Okay, so this is a mock page. Again, we are not entering real credit card information here because that comes with a whole heap of challenges. If you do want to integrate with a third-party payment provider, then that's an option for you, but we're just going to use this mock page. So we're entering some mock payment information, which we're going to pretend is genuine and valid. And if we click on purchase ticket now, we get a HTTP 500, an unknown error. Let's see why. Okay, we cannot invoke the save and flush because the QR code repository is null over in the QR code service. Let's see why that could be. So let's minimize that so we can see. So QR code repository is null because we missed off a final. Perfect. Let's restart the backend. Okay, restarted once more. Let's go back. And if we click on purchase ticket now, thank you. We're redirected back. Let's take a look at the HTTP 204 no content. So it looks like that's gone ahead. There is one way of confirming that though, and that's by going over to, and we'll start off on tickets, I think. So select the data from tickets. So we can see some of my testing here, but we're looking for the very latest one, which will be down the bottom. this one here. So the purchaser ID is the attendee user. Perfect. I can confirm that this is the time right this very moment. So that seems to match up. The ticket type ID is the standard entry for 999, so that works too. Let's go over to the QR codes, select some data. Again, making sure that we get the one that matches the times, the latest one here. We have one active, and we have a big, long base64 encoded QR code image here. And if we click on ticket ID, we should go back to the one, yep, here we are, the one that was purchased just a moment ago. So although we can't yet see our QR code image, and we will see that very, very shortly, it looks like we're able to purchase tickets and generate QR codes, and we can see them here in the database. So in summary, we fixed a null pointer exception bug, we created a ticket in the database, and we created a QR code in the database. So let's recall what we've achieved in the purchase ticket module. In QR code generation design, we updated types in the QR code entity, added a QR code generation exception, and added the QR code service, added the QR code repository. In QR code generation service layer, we added the crossing dependency, implemented the QR code generation. In ticket purchase service layer, we implemented the initial purchase ticket functionality. In ticket purchase endpoint, we implemented the purchase ticket endpoint. And in UI testing, we fixed a null pointer exception bug, created a ticket in the database, and created a QR code in the database. We've generated those QR codes, and next time we'll implement the logic to scan them and to validate our tickets. As a reminder, if you do want access to the community and the resources I've used here today, there's a link in the description below and you can join today for free. Now, if you look up here, you should see the next and last video in this series. And if you don't, it means it's not out yet. So I'd recommend subscribing to be notified when it is released. And in the meantime, why not check this out?